All right, so this is lesson 2. We are now going to convert more than just points. We're going to convert the entire equations from polar to rectangular and rectangular to polar. Your bell work here wants you to convert the polar coordinates to rectangular. So this is just from lesson 1, where if this is polar, we know it is r comma theta. And we want x and y. We want the rectangular, okay? So we're wanting x comma y. So to find x equals r cosine theta. Y equals r sine theta. But we need to also pay attention, make sure we end up in the same quadrant. So 5 pi over 4 puts us in the third quadrant. So we want to make sure we end up there with our x and y. Make sure, well, both of them will be negative, okay? So cosine of 5 pi over 4. Let's see. So if I'm doing x, I need to do it here. X will equal 6 times, and then cosine of 5 pi over 4 is 1 over square root of 2, which is the same thing as saying square root of 2 over 2. So that makes it 3. Well, here, let's do it the way, I'm sorry. This is what happens when I'm trying to record. Okay, 1 over square root of 2. But cosine of 5 pi over 4 is negative. Okay, so that makes this negative 6 over square root of 2, and you can just leave it like that instead of rationalizing it. And then we have y equals r times sine of 5 pi over 4, which is also negative 1 over square root of 2. Okay, so it is also a negative 6 over square root of 2. So this is the rectangular form. And now let's do the, we have the rectangular form, go to polar form. So this is xy. So remember r squared, I'm going to do it over here. So r squared equals x squared plus y squared. That's the equation of a circle. Let's see. So we don't know what r is. So x is negative 4 squared plus negative 4 square root of 3 squared. All right. So sorry. So we have 16 plus, now I got to square both of those things. So negative 4 squared is 16, square root of 3 squared is 3. So I have 16 times 3, which would be 48. So r squared equals 64. So r equals 8. Now, remember we are wanting to end up here in quadrant 3. Okay. So r can be a positive 8. As long as our angle gets us there. And to find our angle, it is tangent theta equals y over x, or theta equals inverse tangent of y over x, of negative 4 over square root of 3 over negative 4. So it looks to me, what is theta when we do inverse tangent of just square root of 3 is what that simplifies to. So we know it's positive in quadrants 1 and 3, and since we're wanting that angle in quadrant 3, so if we think of it like here, if it's square root of 3, that means this was really square root of 3 over 2, and this is 1 over 2. So that should give us a 60-degree angle, which is over 3. So we are doing 4 pi over 3. So we have r is 8. And theta is 4 pi over 3. Now remember, you can write this in different ways. We could have had a positive 8, but you could have gone negative 2 pi over 3. Okay, could have gone counterclockwise. Or you could have a negative 8, and then we deal with angles from the first quadrant. So negative 8 and pi over 3, or negative 8 and negative 5 pi over 3. Okay, so there is the polar coordinates. Now, since points can be written in both rectangular and polar formats, we can also write equations with both formats. So graphs that are linear are best written in rectangular format, while graphs that have curves are best written in polar form. Non-functions with loops are very difficult to write in rectangular form and usually need to be written as a piecewise function, while in many cases are very easily written in polar form. So to convert from one form to another, we use the same relationships listed on the box on page 2, which is just how to convert x and y's and polar things to rectangular things or rectangular things to polar things, okay? So I'm going to end this video, play the next video to do example 1, converting from rectangular equations to polar equations.